We finished learning workbook page 64 by performing step 2 of this problem. An airplane takes 4 hours to travel a distance of 3,000 miles with the wind. The return trip takes 5 hours against the wind. Okay, step 2 is where we write our two algebraic equations describing this situation. This problem involves an object moving at a certain rate for a certain time for a total distance. So the formula that we're going to use here is distance equals rate times time. D equals R times T. All right, so there's two different situations. When the airplane first makes its initial trip with the wind, and then when the airplane makes its return trip against the wind. So each one of those will be an equation on our system. All right, let's plug in what we know. D, distance, that's 3,000 miles. Time, that's 4 hours. Now, it's the rate that we have to worry about. And you want to pay attention to the phrase, with the wind. So think about what's going on here. If there was no wind, then the speed of the plane would be represented by p, the speed of the plane in still air. But when an airplane travels through the air, if it is going with the wind is helping it go faster, which means you would take the speed of the plane, p, and the speed of the wind, w, and you would add them together. So the rate here would be p plus w. This is our equation for the first situation. We'll use a similar approach to write our equation for the second situation. The return trip, so that must also be 3,000 miles, so 3,000 for D, takes 5 hours, so T will be 5 hours. And this time we're going against the wind, so the rate of speed is going to be the speed of the plane minus the speed of the wind, P minus W. These two equations right here form our system. This is equation 1. This is equation 2. And this is the number 5, not an S.